various classes of oxidizing reagents and their application. Introduction. Chemistry is replete with transformations that involve the transfer of electrons between reacting species. This fundamental process known as reduction reaction. Reduction oxidation reaction are ubiquitous in nature and form the basics of countless synthesis and industrial process. At the heart of every redox reaction are two key players: reducing agent and oxidizing agent. While the reducing agent donates electron and gets oxidized, oxidizing agent accepts electron and gets reduced. The field focus specifically on the first word of oxidizing reagent. An oxidizing reagent, often simply called oxidant, is a chemical species that has the ability to cause the oxidation of another substance. In doing so, the oxidant itself undergoes reduction, meaning its oxidation state decreases. The strength of oxidizing agent is often qualified by the standard reduction potential, with higher positive value indicating a stronger tendency to be reduced, as well as a stronger oxidizing capability. However, practical chemical reaction, the actual oxidizing power can be its concentration, including its pH and temperature, and the presence of catalysts or inhibitors. The selection of appropriate oxidizing reagent is critical step in reaction design. The choice depends heavily on the nature of substance to oxidize. The desired product requires selective, e.g., thermoselectivity, radioselectivity, spectroselectivity. The reaction condition is hereby solvent, temperature, and pressure. Ease of handling, cost, and environment impact. The vast array of available oxidizing reagents offer chemists a powerful toolkit for achieving a wide range of chemical transformation. This field aims to provide a structured overview of the major classes of oxidizing reagents commonly encountered in chemistry. Now, we will dive into their characteristics, properties, and their presentative example with each class, and briefly touch upon their typical mechanism of action. And furthermore, we will explore the wide range application of those power reagents across various scientific and industrial domains, highlighting their significance in modern chemistry and technology. The definition of oxidation and reduction. Traditionally, oxidation was defined as the gain of oxygen by substance and reduction as the loss of oxygen. Reduction was also defined as the gain of hydrogen However, the more modern of universally accepted define is based on electron transfers and change in oxidation states. Oxidation, oxidation, oxidation is a process involving loss of electron by a substance or increase in its oxidation state. Reduction is a process involving in gaining electron by substance or decrease its oxidation state. These two processes always occurring simultaneously in redox reaction. The substance that is oxidized is the reducing agent. The substance that is oxidized is reducing agent, which is known as reductant. And the substance that is reduced is the oxidating agent, which is oxidant. The role of oxidizing reagents. Oxidizing reagents facilitates oxidation by accepting electron from substance being oxidized. They can do this in various ways, including direct electron transfer, transfer of an oxygen atoms, transfer of an halogen atoms, or formation of reactive intermediate that abstract hydrogen atoms or electrons that dictate the specific mechanism of their resulting product. Understanding this mechanism is crucial for predicting reactivity, and controlling selectivity in oxidation reaction. The following section will explore the major classes of oxidizing reagents and their specific roles in chemical transform. Class of oxidizing reagents, molecular oxygen. Class of oxidizing reagents. Oxidizing reagents can be broadly classified based on their chemical composition and the elements responsible for their oxidizing power. While some classification might overlap, grouping them helps in understanding their general properties and reactivity patterns. Oxidized and oxygen and oxygen contain compound. Oxygen is a typical oxidation agent, and many powerful oxidants contain molecular oxygen. Molecular oxygen is the most abundant oxidant in Earth's atmosphere, and it is involved in countless natural processes, including respiration and combustion in chemistry. Is a relative mild oxidant understands standard conditions due to its strict ground state, which make direct reaction with many organic molecules. However, it is oxidizing power that can be significantly enhanced by increasing temperature and pressure or by using catalysts. Transition metal complex. It is application large-scale industrial oxidants, for example, production of ethylene oxide and phenol is combustion process biological oxidant. Allotrope of oxygen with a significantly high oxidant potential. It is a potent oxidant used in various applications due to its ability to react rapidly with a wide range of organic and inorganic compounds. The mechanism of ozonolysis of alkenes is a classic example, evolving for formation of an unstable ozonide which, which is then cleaved to carbonyl compound. Ozone can also ozone can also it is application again. Water and what water and wastewater. Water and wastewater treatment, disinfection and oxidation of pollutants, bleaching of pump and texture, organic synthesis. Application application on it is organic synthesis, oxidation and alcohol alkalines, oxidative cleavage, water treatment, oxidation, organic contamination, and ion manganese removal, analytical chemistry, redox, titration, etching, halogen and halogen compound. Elemental halogen are potent oxidating agents with their reactivity decreased down the group. Their oxidizing power stems from their high electrogravity and tendency to gain an electron from allied anion. Elemental halogen, chloride and bromide, chlorine and bromide are widely used as oxidants in industrial processes and organic synthesis. Iodine and major oxidants, often used in specific organic transformation. Fluorine is the most powerful elemental oxidant. Fluorine is the most powerful elemental oxidant, reacting vigorously with most substance, and it is used typically limited to high specialized application due to its extreme reactivity. N-halo compound, N-bromo bromosuccinimide and N-dodeoxyximide. These compounds contain halogen atoms bonded to a nitrogen atoms are often control radical halogen reaction. They are milder and more selective alternative to elemental halogen for certain applications. Their mechanism: hot concentrated sulfuric acid can oxidize non-metal like carbon and sulfur, and less 6 oxidant state is reduced typically to SO4. Application in industry: industrial process catalysts, dehydrating reagents, oxidating reaction at high temperature. Peroxosulfuric acid, and H2SO4. Ferrous acids contain peroxide bond, and it is a powerful and versatile oxidant. Application: bleaching agent, oxidating of sulfide, amine, and other functional groups in organic synthesis. They are metal oxidize and salt. Several metals oxidize and salt, where the metal in high oxidation state act as effective oxidizing agent. Heavy metals oxidize like OSO4, sulfur 1 oxide in amide oxidant, sometimes used for oxidating aldehyde and benzylic alcohol. Osmium tetrosulfate is a high toxic but effective reagent for the synthetic. The application of oxidizing agents. The facility of oxidizing reagents make them indispensable tools across a wide spectrum of chemical discipline and industrial process. Organic synthesis. Oxidation reactions are fundamental transformation in organic synthesis, enable the conversion of fundamental enable the conversion of functional group to another, or construct of a complex molecule architecture. Alcohol oxidation. One of the most common applications in the oxidation of alcohol to hydrolyze, aldehyde, and ketones are carboxylic acid. The choice of oxidant dictates the product. The choice of the oxidant dictates the product. Primary alcohol can be oxidized to aldehyde using mixed reagents like PCC, PDC, swaying oxidant reagents, or des-methyl periodine 17, 34, and 33. Stronger oxidants like KMNO4, KRO3, or hot concentration in HNO3. Why oxidant primarily alcohol to carboxylic acid 15, 16, and 22. Secondary alcohol are typically oxidized to ketones by a variant of oxidant, including chromate, permanganate, and middle reagents. The tertiary alcohol are generally resistant to oxidation unless as conditions that cause CC bond, which is cleavage bond, are employed. We move to safety and handling consideration. Many oxidizing reagents are hazardous. Material that require careful handling, storage them carefully, and use. They can be corrosive, toxic, and strong. Oxidizer can react violently or explosively with flammable or easily oxidizable material. Proper personal protective equipment, ventilation, and adherence to safety protocol are effective when working with this substance. In conclusion, oxidizing reagents are diverse and powerful class of chemical substances indispensable across nearly all areas of chemistry and numerous industrial and environmental applications. from simple molecular oxygen to complex hypervalent hydrogen compounds. Each class of oxidants possess unique properties and facilitate the oxidation of other species drive fundamental transformation in organic synthesis enable the product of essential industrial chemical facilitating the diffection and purification process and plays a crucial role in environmental remediation. This continued development of new and more selective oxidant reagents, coupled with a deeper understanding of their reaction mechanism, remains an active of a research. The increasing emphasis on green chemistry is also driving the research for more environmental, environmentally being oxidants and oxidation process such as use of oxygen or hydrogen peroxide with suitable catalysts and implementation of electrochemical oxidation. Thank you.